this video from yesterday and you understood the questions we just did, you should be ready for tomorrow's quiz. If you understand, so let's begin. Let's analyze this graph and let's understand which possible function this graph could be. So we know that, how about this? Let's go with what we know it's not, okay? We know that this is a 1, 2, 3. It has 3 directions, up, down, up. So that's a third degree function, which means it cannot be C, because C has the degree 4, so it cannot be C. We know it has 3 directions, so it has to be a degree of at least 3. It could be 3, it could be 5, it could be 7. And as you can see, the rest of them are 3, so that's good. Now we do also know that the end behavior is down here in quadrant 3 and up here in quadrant 1. And that's similar to the most basic function that has an odd degree, which is y equals x. It has the same end behavior, which means that the leading coefficient is positive. It's not negative. Does that make sense? So the leading coefficient is positive. It's not negative, which means I could eliminate option B because it has a negative value as your leading coefficient. So we know that the negative leading coefficient would give you end behavior in quadrant 2 and quadrant 4, right? Up here and down here. But that's not the case. So it cannot be option B. So let's scratch that out. So what else? What else? So we have the rest of them that are third degree functions. Now, we need to determine whether it's A, D, E, or F. Now, what we're going to do is truly understand what a graph is. A graph is technically a bunch of solutions to the system. It's really, not to the system, to the function. I'm sorry, a bunch of solutions to the function. What does that mean? X values and Y values. The X values are the inputs, the Y values are the outputs. So technically, when I name any coordinate here, and the easiest, I guess, to deal with is that one right there. That coordinate is the coordinate 0, 2. That's the y-intercept. And finding the y-intercept on a standard form quadratic, or a standard form polynomial function is the easiest thing in the world, because when you input 0, and there's x's everywhere except for your constant, your output will be your constant, right? So what this is saying, what this coordinate is saying is that when you input 0, your constant is your output, your 2 is your output. So if I put a 0 here, 0 cubed minus 3 times 0, that's 0 plus 1 is 1. So this function has the input 0, the output 1, which would be down here, not up there. So we need it to be 0, 2. So it's obviously not A. The C value was 1, and we need the C value to be 2. So it cannot be D either. Because the C value is 1, we need that C value to be the y-intercept, which is the y value of 2. So it cannot be D either. Does that make sense? I hope so. Now, let's take a look at E or F, because both of those have the constant 2, which means if I did plug in the input, the X value of 0, I will get that output of 2, right? Plug in a 0 there, do the work, it'll give you 2. 0 there, do the work, it'll give you 2 also. So how the heck am I going to know the difference? Well, I'm going to pick another point, right, to see if it works. Another input and another output. So which other nice coordinate would you pick? Anybody? Anybody? Okay, maybe my 1, 1 is an excellent point. I was thinking my internet wasn't working. But yeah, 1, 1 is an excellent choice. The coordinate 1, 1. So the coordinate is really an xy value. It's really the input 1 giving you the output 1. So which one of these, when I plug in, will actually give me that output? So if I plug in a 1 for x, 1 cubed is 1, 2 times 1 is 2, 1 squared is 1, times 3 is 3. So you have 2 minus 3, that's negative 1. Negative 1 plus 2 is 1. So this one gives us the 1, 1. So far it looks like E is the correct answer. But let's double check and make sure that it doesn't work for this one. Because if it does work for this one as well, then we need to test a different point. Maybe like this coordinate right here, which would be -1, -3. But let's plug in 1 for x and see if it works on option F. 1 cubed is 1, 2 times 1 is 2, 1 times 3 is 3, 2 take away 3 is -1, and -1 plus 2 is also 1. Right? Yeah, that's not cool. Okay, so it might be F as well, but let's plug in a different point. So let's plug in this coordinate right here. I hope that's a coordinate, -1, comma, -3. So if I plug in a -1, that'd be -1 to the third, that's -1. 2 times -1 is -2. Plug in a -1 there, that'd be a +1. That'd be a -3. So -2 and -3 is -5. -5 plus 2 is -3. So this one gives us the coordinate -1, -3. So it looks like this one's the correct answer, but let's try the bottom one as well. -1 right there will be a -1. Over here, when I plug in the -3 times the -1, that'll be a +3. So I will end up with a -2 plus 7, pretty much. So that'll give you a -5, and we know that option F does not have the coordinate at -1, -5. It has it at -1, -3. So it's definitely not F, it is E. Okie doke. And I promise there will be 1 or 2 of these questions on tomorrow's quiz, so please make sure you know it. Let's take a look at this guy right here. Same difference. Which ones could we eliminate? Somebody tell me, which ones could we eliminate? And you don't have to name all of them. Just give me one that we could eliminate. One that you're like, for sure, that one cannot be it.
B.
B, for sure. B cannot be it because it has a negative as your leading coefficient, which means you would have your end behavior up here and down here on the cubic function, right? So definitely eliminate that one. Is there any other one we could eliminate?
Why don't you eliminate E and F?
E and F, absolutely, yeah. Because E and F have the constant of 2, which means that if I were to plug in 0 for x's, my output should be 2, which means the coordinate 0, 2 should be on this graph, and 0, 2 is not on this graph. This is the coordinate 0, 1. So that was a good point right there. 0, 1 is the correct point on the graph, not 0, 2. So we could eliminate E and F. What else? We could eliminate, which other one could we eliminate easily?
C.
C, absolutely. Why could we eliminate C? Because it has the degree 4, which would mean that you would have to change directions 4 times at least, right? And it goes up 1, 2, 3. Only 3, cannot be 4, so we could eliminate C. Let's eliminate C. So it's either A or D. So let's plug in a point and see if it works. Which one should we do? Pick a coordinate. Anybody?
Wait, can you still use 0, 1 or not?
If you use 0, 1, since you know it's a point, it's going to work, but it's going to work on both because they both have the C value of 1. I mean, so if you plug in 0 here, 0 there, do the math, yeah, you're going to get 1. 0 here, 0 there, do the math, you're going to get 1. So it didn't really help you on determining which one's the right one. So instead of 0, 1, give me a different point.
2, 2.
2, 2. Okay, so here's a little tricky part. Is that really a coordinate 2, 2? Or is a coordinate at 2, 3? Or is a coordinate at 2 and maybe 2.5? Who the heck knows? It's kind of hard to determine where it actually is at right there. So pick a clean point. Either pick this point right here, -1, +3, or maybe 1, -1. I'm going to go with this one up here. Plug in the coordinate -1 for the input and see if you get a +3 for the output. And if that does work, then that pretty much tells you that that's your equation. So plugging in -1 for x to the third, -1 times -1 times -1 is -1. -3 times -1 is +3. So 3 minus 1 is 2. 2 plus 1 is 3. It looks like this gave us the output 3, which means this would be the correct point. This would be the correct function. Let's see if it gives us the same output over here. When I plug in -1 right there, that gives us a -1. -1 to the third is -1. -1 squared is positive. -3 times +1 is -3. You have a -1 and a -3. That's -4. -4 plus 1 is -3. So this would give you -1, -3 as a coordinate. -1, -3, it would be down here, not up there. So that one's definitely incorrect, and we knew that this one is the correct one right there. I know that that sounds pretty confusing, but it really isn't. Once you understand that a graph is just composed of infinite amount of inputs and outputs based on your function, you should be able to use those nice clean points to verify which input gives you the appropriate output, okay? Once again, the C value right here should be 1 based on the fact that when you plug in 0, you get out a 1. So if you plug in a 0 into your x's, you should get out a 1, and that's a 2 right there. So you could eliminate, again, E, F. What else? We could eliminate the power of 4 because it only goes up, down, up. That's 3 directions, so it has to be the degree 3, which is either A, B, C, or D. We could eliminate the -1 because we know if there were a negative leading coefficient, you'd have end behavior in quadrant 2 and quadrant 4. Same reasoning as before. So it's either A or D. Now we already know that 0, 1 works right here and right there. So let's pick a different point. Anybody have a different point they want to use? Give me a coordinate, guys. A nice one.
2, -3.
2, -3 looks good. You could, and probably another good one is 3, 1, or maybe -1, -3. Ricky, you had a question?
No.
Your mic's on.
Nice.
You just said, "Why do you do this to me?" Okay.
Yeah.
Okay. So anyway, we're going to go with what Keith said, 2, -3. Plug in a 2, see if you get out a -3. So when we do the top one, 2 cubed is 8. 3 times 2 is 6. 8 take away 6 is 2, and 2 plus 1 is 3, not -3. So for sure it cannot be A, which means that it must be D. And we could verify that by plugging in 2 and seeing if it gives us out a -3. 2 to the third is 8. 2 squared is 4. 4 times -3 is -12. 8 with the take away 12, that's -4, and -4 plus 1 is -3. So D is the correct answer for that one. If you understand that and you understood what we did today in class, analyzing polynomial functions, you should be ready to ace the quiz tomorrow. Okay, now what do I mean by what we did earlier?